Oof, the air in here is not ideal. If only I could go back in time and monitor the air quality and have it warn me to close the windows. Wait, there is a way to do that. RedisTimeSeries to the rescue. Let's check it out. RedisTimeSeries is a component of Redis stack that adds a time series data structure to Redis. As you'd expect from Redis, RedisTimeSeries can quickly ingest data samples while still providing low latency reads. And of course, there's a suite of commands that allow you to tailor your data for real-time tracking, secondary indexing, and even control over the data structure's size. Let's spend some time covering the basics. For today's example, we'll be taking sensor readings of the air quality around my house to alert us when we need to close the windows due to smoke or particulates in the air. We'll use a Wi-Fi enabled Raspberry Pi compute unit attached to an air sensor to take a sniff every second outside my house. We'll create 2 of these remote sensors to track the quality of the front and back of the house. We then send each device's readings to RedisTimeSeries, which is hosted on Redis Cloud. We can then create a service to monitor the values and send an alert when the threshold of clean air has been passed. Time series commands are prefixed with TS. Followed by the actual command. To create a time series in Redis, use the create command followed by the key name. For our 2 sensors, we'll use particulate-sensor:1 and particulate-sensor:2. We are now able to make a few decisions about our object's behavior with some optional subcommands. Adding the retention option allows us to set how long in milliseconds previous events are kept since the most recent event insertion. Let's say we want to keep the most recent 7 days of sensor readings. We'll want to set the retention time to 604,800,000 milliseconds. Chunk size specifies the initial amount of memory reserved for our time series. The default is 4096 kilobytes, but we can choose any multiple of 8. The size will double as more space is needed for the data structure. We'll set the initial chunk size to 16,192 to give us plenty of space to work with. Duplicate policy lets us decide what to do if a sample with the same timestamp is inserted. Should we go with the default and block it? Should we replace it with the newer one? Replace it if it's larger? Add the values together? The decision is unique to each use case, and for our particular case, we can choose to replace the sample with the newest reading, just in case we want to replace obvious errors with an average value. Lastly, we can add label value pairs to the key for secondary indexing. This will help with querying, which we'll cover later on. Now that we have our 2 time series created, we can add samples using the add command. We call add, then the specific key, then we include a timestamp in milliseconds that we want to associate with a sample. We can also use an asterisk to let Redis set the timestamp based on a Redis server system clock. We can also use add to instantiate a new time series object and add an initial value. Retention, chunk size, duplicate policy, labels, and all other options are also available at this point as well. As we use our time series and observe its behavior over time, we might need to adjust a few key-specific settings to better suit our needs. If we need to update the options assigned to an existing time series, such as the retention time, duplicate policy, and the existing labels, we can use the alter command. We can do this by calling alter with the key we want to update and the options we want to change. Note that any changes you make with alter replaces the previous configuration of your time series. A time series often contains a large quantity of samples. We may want to retrieve a portion of our time series to view only samples representing a specific hour, day, or time frame of our choosing. To get samples for a given time period from a time series, we use the range command. This command's parameters include start and end timestamps. These specify the boundaries in which we want to retrieve the time-stamped samples. Range has some options that help us get insights into our time series samples. We can use filter by value with the min and max value pair to only receive the timestamps and samples within those 2 values inclusively. Using the air quality sensors example, I can call range on a time series with the filter by value option. When I specify a minimum value of 51 and a maximum value of 100, I'll get a result containing samples where air quality was in that range. This is considered to be moderate air quality. If I filter for values between 101 and 150, I would receive all of the timestamps that have unhealthy air quality values. Lastly, with the range command's aggregation option, we can aggregate values over a specified time range to find the sum, the maximum, the minimum, and the average. This is great for taking samples from your time series without computing aggregate values from the entire set of data points yourself. It should be noted that there is also a revrange command that works exactly as the range command, only in reverse. This means that the range will by default travel from the most recent values to the oldest. This is preferable if you want to traverse recent timestamps more often than ones near the beginning of the time series. The range commands are great for when we want a specific zoomed-in view of the samples or want to retrieve a specified sample range as a computed average. As an example, if we're sending our time series to a monitoring service, such as Grafana or Prometheus, the range command would be called anytime we want to inspect our samples through a rolling 24-hour period or the last hourly average. One of the more interesting and useful commands within the RedisTimeSeries module is CREATERULE. This command adds timestamps and samples from one time series to a second time series in an aggregated form. This is great for data compaction and custom value tracking. Let's say I want to see a graphical representation of the samples from my two air quality sensors. I can connect Redis to Grafana, a data visualization platform, to see the air quality over time. This is great, but quite costly for Grafana to consume a day's worth of samples from my time series to create this view. We'll create a new time series called particulate-sensor:1:average:10, store average values in 10-minute time buckets from our original particulate sensor 1 time series. We call CREATERULE with the destination key, the target key, the aggregation option with the aggregation type, and time bucket in milliseconds. Here I am choosing average and 600,000 milliseconds, or 10 minutes. The new time series will now take the average of the last 10 minutes of samples and create a single data point. There will be fewer samples in this time series, but this is perfect for data compaction, where we're not interested in the granular values, but more of an overview. This is especially great for visualizations, as the view is less crowded, the size of the time series is smaller, and the rendering takes less time. There are many other aggregation types, such as sample count, sum of values, min-max values, standard deviations, and variances of sample sets and populations. Make sure to check the documentation for the full rundown of every command and its options. Let's expand on the air sensor example a little. Imagine we had a large fleet of air sensors dispersed throughout our town. Maybe we'd like to search for sensors that might have certain zip codes, street names, districts, or location types, such as residential, commercial, or industrial. The Redis time series has a query index command that could help with such a search. This allows us to query across all the time series keys to find matching or non-matching labels and values. Here are a few of the query filters that you can use with the labels. These are great if you want a list of all the keys with the same label value, but not necessarily all the values with only one key. We've only just scratched the surface of what Redis time series can do with time-stamped samples. Finance and stock market analysis, real-time device monitoring, factory production tracking, historical data analysis. The possibilities are limited only by your imagination. If you would like to learn more about the Redis time series module, including more commands and options not included in this video, head over to our documentation at redis.io. You can always sign up for a free Redis stack database in the cloud to start experimenting with Redis time series. So the next time you find that you're inundated with information and want to keep track of everything, let Redis time series do the heavy lifting for you. You'll watch in amazement just what you'll be able to accomplish. Breathe easy, and I'll see you next time.